voltage E into exponential power minus AT is applied at time t is equal to 0 to an electric circuit contains an inductance L and resistance R. Determine the current at t greater than 0 given that E, R, L and A are constants and initially the circuit contains no current. So this is a problem as before. Take the given data, that is given that the current I in the given circuit is generated by the differential equation L into di by dt plus Ri, which is equal to, here voltage is given by E into exponential power minus AT. Next step, you have to divide throughout by L. Call this as equation number 1. Divide throughout the equation by L, we get a linear differential equation of the form di by dt plus R by L into I, which is equal to E into exponential power minus AT divided by L. Here this is a differential equation, that is linear differential equation, where P is R by L and Q is E into exponential power minus AT by L. Next step, we have to find the integrating factor, that is integrating factor is exponential power integral of P of x into dx. Here in the place of x you have to substitute as t, so that we can take it as exponential power integral of P is R by L into dt, which is equal to, here take R by L as common, integration of 1 into dt is t. Therefore we get an integrating factor value as exponential power R by L into t. Next, the solution of an equation is given by the formula I into integrating factor, which is equal to integral of Q into integrating factor plus C. Substitute E integrating factor value and Q value, we get as I into exponential power R by L into t, which is equal to integral of Q is E into exponential power minus AT divided by L into integrating factor is exponential power R by L into t into dt plus C. Next step, take E by L as common and remaining is I into exponential power R by L into t, which is equal to E by L if we take as common, remaining is integral of exponential power of, here we have E power minus AT into E power R by L into t. If the bases are same, we can add the powers, so we can take it as exponential power, positive sign first, R by L minus A into t into dt plus C. Now we have to find the value of integration, that is I into exponential power R by L into t, which is equal to, here E by L is constant as it is into, here this of the form integral of exponential power ax, so we can take it as exponential for ax divided by a. Here in the place of a we have R by L minus a, in the place of x we have t, therefore we can take it as exponential power R by L minus a into t divided by R by L minus a plus c. Next step, take a LCM as L over here, we get as I into exponential power R by L t, which is equal to E by L into exponential power R by L minus a into t in the numerator as same, divided by, here if we take L as LCM, remaining is, we get R minus AL divided by L plus C. Here we can cancel this L term and take this value to the right hand side, we get a value of I as E divided by R minus AL is constant, take outside, into, here we have exponential power R by L minus a into t, we can split it as exponential power R by L into t into exponential power minus AT divided by, this value goes to the denominator, that is exponential power R by L into t plus, also this value goes to this value, that is C divided by exponential power R by L into t. Here we can cancel this exponential power R by L into t value here. Here if we take this value to the numerator, we get as I is equal to E by R minus AL into, here remaining is exponential power minus AT plus C into, if we take this value to the numerator, we get as exponential power minus R by L into t. So call this as equation number 2. Next step, we have to find the C value. For that, take the given data, that is initially they have given current I is equal to 0 when t is equal to 0. So substitute I value as 0 and t value as 0 in equation 2. We get as 0, which is equal to E by R minus AL into exponential power minus A into 0 plus C into exponential power minus R by L into 0. Here this value becomes 1. Here also this value becomes 1. Remaining is 0, which is equal to E by R minus AL plus C. So if we take this value to the left hand side, we get a value of C as minus E by R minus AL. Next step, substitute this C value in equation number 2. Here we have to substitute C values minus E by R minus AL. We get I is equal to E by R minus AL into exponential power minus AT plus, in the place of C we have to substitute as minus E by R minus AL. So plus into minus becomes minus E by R minus AL into, here exponential power minus R by L into t as it is. Next step, we can take E by R minus AL as common over here. We get as I is equal to E divided by R minus AL into, here remaining is exponential power minus AT minus, here we have exponential power minus R by L into t. So this is a value of current at time t greater than 0 under the given initial condition. So we can conclude that this is a current value I at time t greater than 0 under a given condition. This completes the problem. So these are all the problems related to LR series circuit.